Welcome to clickmyproject.com. Now let's see about optimal transport for secure spread spectrum watermarking of still images. Here we propose the technique for embedding the images to secure the watermarking. For embedding the images, spread spectrum algorithm is used. Signals are spread with the different codes so that they can spread it at the receivers. Signals can be spread in the frequency domain or in the time domain. For extracting signals, we decompose the images by the wavelet. It will extract the low and high frequency. Extracted frequency is embedded with the cover images. And finally, we calculate the PSNR and MSE values for analyzing the quality of images. For spread spectrum schemes, the detector or the decoder's performance is reduced by the host interference. Thus, we came up with the new host interference rejection idea for MMS scheme. In this work, we call this new host interference rejection idea an enhanced multiplicative spread spectrum scheme. This is the flow of our process. Here we have to give only two images. First one is the cover image, second one is the message. Initially we have to convert the image as a frequency so that we can use the wavelet transform. By the use of wavelet, we have extracted the spectrum frequency by wavelet. After applying the wavelet, we have getting the low and high frequency. For two images, we also get low and high frequency. Before applying wavelet, we have applied the Gaussian modulation for the input images by the use of key, so that the images will be converted by the key. After that, we have extracted the wavelet transform. The extracted low and high frequency will be passed to the fused stage. In this stage, we have fused the low and low frequency to the one fusion and high frequency to the second fusion. Here we embedding the frequency by the use of alpha embedding. After this fusion, it will go to the inverse transform. After inverse transform, we have finally getting the fused images. Now let's see the demo for process. Here I am having main Addons file. Select this file, right click and run the file. This is our guide design. We have to given the input image. This is the message. We are gonna embed with the cover image. This image going to the pre-processing stage. Here we have to remove the noise. So the different level of filtering coefficient is given 3, 4 and 5. So based on the level, the filtering will be applied. Now I am selecting 4x4 level as a filter. So the image is filtered. After that we go for a Gaussian projection. So initially we have to generate the key for convoluting the images. After generating the key, it goes for the Gaussian modulation. Now we have modulated the images and click on next. In this stage we have calculated the spread spectrum, so that we have to select the cover images. In this cover images, this is the identified spread spectrum for the given input images. This is the cover image, and then finally we go for embedding. This is the value for alpha embedding. You can select any value. Now I am selecting one value. This is the watermarked image. Then click on next for detecting the watermarking. The watermark is passed here. Initially we have extracted the watermarked images. So the extracted image is displayed here. After this we go for the image reconstruction. This is the decrypted image which we have given as a message. Now let's see about the existing method. In existing we have used the SVD. So the SVD watermarking is showing differently. So it is showing it has some message. After that we go for analysis. This is the comparison graph for MSC values between the natural watermarking and transportation natural watermarking. This is the PSNR value. The PSNR values of extracted image is higher than our existing system. Now I am showing the result of watermarking by the use of spectrum. It's showing the better result than the existing system. Thank you.